if we just start with this, your electromagnetic induction. So we have seen that, just I told you. So likewise, that experiment done by that Oersted, where he has found that so the needle has got deflected when there is a flow of current through that conductor. So that means the flow of your electrons, so that is nothing but the electricity is responsible to produce the magnetic field. Now we have to just check the opposite of that, the reverse of that. That means, can we generate the electricity with the help of your magnetic field? So this is nothing but the electromagnetic induction. Induction means obviously it is induced. Yeah, so the electromotive, that is nothing but the, you can say, EMF has been induced in a circuit, yeah, or across the conductor whenever the flux link with that coil that has got change. So definitely we can say it is a process of your induced EMF because of change of your magnetic field. Yeah, so that is electromagnetic induction. So this is process of generating electric current with a magnetic field. So that is your electromagnetic induction. So it occurs obviously when we just say that, so the magnetic field, I just discussed that. So then definitely the magnetic field and electric field, how they are just going to relate, so that we will see in this electromagnetic induction, and which is obviously the cause of your electromagnetic induction. So let's start with this topic of your magnetic flux. So what is this magnetic flux over here? The flux, we can say that it is a kind of flow. Yeah, so it is a kind of flow, so that we can say for this particular case over here. So let's say if I consider the magnetic flux, so that is nothing but the number of magnetic lines of force crossing the given surface normally. So that is what we called it as nothing but your magnetic flux over here. So let's say, for example, in the diagram also you can say, so this surface is also having certain direction. So whatever which I have shown over here. So let's say, for example, consider this. Let's say I will just show you one surface. Yeah. So now this surface is also having certain direction. So let's say this is the direction of this surface, and let's say the magnetic field is just I have shown over here. Okay. So now for this case, the flux, that is the, you can say, flow, that is a flow. So the number of magnetic lines of force which are going to cross, so that is given by the formula, that is a B bar dot A bar, so which is BA cos theta. So if theta is equals to 0, so then we can say that, so your phi is equals to BA. So in that case, the maximum flux will cross. Yeah, so you will get the maximum flux when the angle between B and obviously that direction of surface, the angle between them is 0. In other cases, so let's say, for example, so if this surface is having certain direction, if it is making certain angle with magnetic field, so let's say that angle is theta for this case, then definitely you can write it down. So this is your B bar dot ds bar. Yeah, so that is nothing but how we can say that, so this is BDS cos theta over here. So for that, again you can use the technique. Yeah, so just select a very first of all area. Yeah, so definitely you can just select a small area for that. Yeah, and you have to just calculate the number of magnetic lines of force. Yeah, so that is, let's say the flux will be d phi, so which is nothing but B bar dot ds bar. So now to find the flux passing through the entire area, so for that purpose obviously you have to just take that integration. Yeah, so in that case, then definitely you will get the answer, which is nothing but, let's say it is obviously that is BDS. Yeah, so you can just take that. Yeah, you can just easily find out that value over here.